All right, so here is the wrap up on the parallel circuits. I'm getting bored of that color. Okay. All right, so let's take a look. Here's a nice picture of what a parallel circuit looks like. All right, and we want to talk about each thing. So let's start with the current. All right, so overall, what happens to the current in a parallel circuit? All right, so when I have like this, all right, this is giving the charges one path to travel on. Okay, this is more like a series circuit. All right, when I add another resistor in, okay, what's going to happen now is this this current, whoops. Okay, the charges now, as those charges are coming around, remember they're already everywhere, right? So let's don't get confused about that. Okay, so they're already everywhere. Okay, and then they're going to start, and yeah, why no plus. Okay, once a certain charge reaches this spot right here, it has a choice. It can either go on this path or this path, but it can't go on both, right? So maybe one charge is going to go this way, the next one that comes by is going to go down, then maybe the next one's going to go to the right, the next one's going to go down. So what happens now is we're going to have this current going through each branch. Okay, so if this has a 1 amp current and this has a 1 amp current, right, when they join back together, they're going to have 2 amps. Okay, so it would be 2 amps up here. Okay, same way, if 2 amps of current are coming through the top here, it's going to split. One's going to go one path, one's going to go the other path. Okay, again, they'll split equally as long as each path is of equal resistance, right? If it kind of like they're the same path, they'll just split equally. Okay, next week we'll learn what happens if they don't split equally. But for now, hopefully you just kept the simulation pretty similar. They should just be the same. Okay, if they're not, then you know you messed up something with the resistance, which is fine, just more confusing. Okay, all right, so every time I add another branch in, right? So like this branch also could support 1 amp of current, right? So then that means the overall current is going to be able to be 3 amps, right? So each branch that's added is going to be able to support another amount of current, and that's going to keep making the overall current go up, okay? So more resistors in parallel actually increases the overall current. Okay, right? So we know when there's an increase in current, that means there's a decrease in resistance, right? So even though I'm adding these little roadblocks in, it's actually making it easier to get around the circuit. Okay, so you want to think about why is that happening? Why is it now easier, even though I'm adding, say, more toll booths or more roadblocks or more construction zones? I'm adding more of those, but still it becomes easier to travel around. Okay, so again, think about your freeway example, right? So let's say we want to go to Tahoe, right? A couple ways to get to Tahoe, right? So we're all going to take, let's say, I-80 up there, right? Well, let's say that there's some accidents on I-80, all right? If we split apart and then some of us go around the bottom of the lake, right? Maybe we go on I-50. Now, even though there might be an accident on that road also, it's easier for us to get through because we each only have to pass one accident. Okay, so then maybe there's another accident, but we add it onto another road and then we open up another path, like I-99 or whatever goes up there, okay? So we're going to keep adding accidents, but on a new road, right? So even though there's an accident, we're limiting the amount of cars that have to pass each one, okay? So we could keep adding accidents, but if we keep adding another road, that's going to overall make it easier to travel there, okay? All right, so let's look at another example. Okay, so another one would be, right, like what we talked about with like the checkout. Right? So like, let's say that there's only one checkout open at the grocery store, okay? And everyone has to get through it, all right? If we add another checkout stand, right, more people can split and go this way. If we open another checkout lane, more people can go this way, right? So the more paths that we have to travel, it's going to keep getting easier and easier and easier to get through, okay? So when you add resistors in parallel, even though it's kind of counterintuitive, right? More resistance means, more resistors that I add less resistance because I increase the paths, okay, which overall will increase the current, right? Because each branch can support its own, like say 1 amp of current. So the more branches that I add, the bigger this overall current can be when they come back together, okay? So they'll split, 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 and then they kind of all come back together to make the total. Okay, so that takes care of the resistance and the current. All right, so the other thing was the voltage. Okay, and this one's not quite as intuitive. We'll have to kind of make it up. Okay, so this one is the one that has like the miracle mother, right? So say mom has only $10 to give, right? Like a miracle, right? Everybody's going to get $10. Magic. Okay, right? So the voltage drop across each resistor is equal. Okay, each one is going to get it. And so if you think about it, like with my favorite example of the little dudes with the cup, right? The little dudes carrying the cup of energy around, right? Okay, everybody has a full cup of energy. Okay, by the time those charges get around to the bottom of the battery, they have to have dumped that out somewhere. They have to have dumped that cup, right? So say this guy goes down this path. He only has one place to dump, right? So he has to dump his entire cup here because there's only one place to do it so that he ends up empty when he comes back through. Okay, maybe this guy passed the first path. He didn't want to go that way. He decided to go on the second path. Okay, again, he also only has one place to dump his energy, right? So that he's empty when he comes back, right? So they always have to be empty when they come back. So they're going to dump out the energy to whichever resistors they encounter, okay? So even though there are 3 resistors in this circuit, each charge is only going to pass through one of them, right? You know, this guy going through here, he passes through here. Okay, so the voltage is the same across each one. All right, okay, so let's take a look at the chart. Okay, so in parallel now, we're gonna have current, voltage, and resistance. Oh, I can't spell. Okay, and this is the summary basically of what I'm going to want in your final product, your poster, your Prezi, your video, whatever you're making. Okay, all right, so in a parallel circuit, when I add more resistors, okay, add resistors, the current goes up overall. Okay, each path can support more current, something like this, right? I'm adding more paths, which overall means more charges are going to be able to get through. Okay, so when I add resistors, they go, okay, and then the current total is going to equal all the current in the branches added together, right? Because all those charges are going to split apart, and then they're going to come back together to make the total. Okay, as for voltage, the voltage is the same in each branch. Okay, the voltage is the same in each branch, right? Everybody is getting a dumping of a full cup of energy, right? Because only some guys are going this way, some guys are going this way, some guys are going this way. Okay, so I would say the total voltage is V1 equals V2 equals V3, right? Everybody is getting, in this case, say a 10 volt drop, right? Because everybody has to get an empty cup by the end. Okay, resistors, when you add resistors in parallel, the overall resistance decreases. It becomes easier because why? There are more paths, right? Even though you're adding more resistors, you're adding another path, which sort of outweighs that, okay? All right, and then if you want to know the equation for this, you do not have to know this and you do not have to include this, okay? But it's a little bit confusing. So you're actually adding the reciprocals of them. Okay, if you're like, what is this? Don't even worry about it. Okay, but later, some of you might want to do a little bit of challenge work. You're going to need that equation. Okay, but I will never really ask you that. You don't need to know that. But you do just need to know that when I add more resistors in parallel, the resistance goes down because it's now easier because there are more paths. All right, okay, so that's the end of that. So that's what you are thinking about for parallel. Make sure you have all that clear in your head, and then be ready for your final product next week.